Okay, so we're over here on the 3.3. I maybe even finished with 3.3 today, in which case I'll start 3.4. So it's good to get a little bit ahead, again, in case something goes wrong, as has already happened, as we know. We have some buffer days at the end also. Right, so our next exam is not until Friday, October the 9th. Again, buffer day doesn't mean holiday. It just means in case something goes wrong, I have extra days. And something has already gone wrong, right? I was out for a whole week. So if I get ahead, that's great. So be it. Okay, so we're having a quiz tomorrow. Quiz will likely be 3.2 and 3.3 material. So 3.2, 3.3. And you know the way the quizzes are, so you don't really have to study anything for the quiz. I mean, you get to use your book, your notes. You can talk about it. I'll put you in your breakout rooms. And then you have the whole weekend to work on it. And it isn't due until class time on Monday. Is that right? So the quizzes, the way I'm doing quizzes this semester is very low key. Again, you guys sort of have it nice under this COVID situation. Usually my quizzes, if we were meeting on campus, they would still be on Friday, but it's what you normally think of as a quiz where, you can't talk, you can't help each other out, you can't use your book, you can't use your notes. I'll probably just give you like 10 or 15 minutes to do the quiz and then you turn it in. But now they're supposed to saying, okay, let's make it easier for everybody. And so this is the way I'm making it easier for you. For quizzes, it's very low key. You really don't have to study much, and you could use all your resources and talk about it, and you have the whole weekend. Okay. All right, so we'll get started. And so I am somewhere here, 3.3, and again, I might sneak in some of 3.4. But according to the schedule, if I only got up to 3.3 for the whole week, then I'm good. Okay, so if I sneak in any of 3.4, it's just extra. Okay, and then tomorrow I'll probably only lecture, I don't know, half an hour at the most, I'm guessing, and then break you loose for your breakout groups for the quiz. All right. All right, so getting back to 3.3, I was going to do number 25 for you. So 3.325, of course, ignore any dates that you see here. So what are we doing? You're given a polynomial, and we're asked to factor it completely after finding all possible rational zeros of the polynomial. Okay. You might have to find irrational zeros. To do that, you might have to use a quadratic formula. All right, so I was going to show you 25 right now. X cubed plus 2x squared minus 4x plus 1. All right, so I'll show you the long division. But along with the long division, we're going to learn something else called synthetic division. Okay, synthetic division. I'll get to that in just a moment. All right, so what are the possible rational zeros? Well, we said it's going to be a factor of this, the constant, divided by a factor of the leading coefficient. Well, all you have is 1. What are the possible factors of 1, plus or minus 1? Same thing for this. So the only things to try are plus or minus 1. That makes it very nice. Okay, so I plugged in 1. You can kind of tell if you plug in 1. 1 plus 2 plus 1 is 4. 4 minus 4 is 0. The nice thing about plugging in 1, you put a 1 here and a 1 here, you're essentially just looking at the coefficients, the numbers that are in front. So 1 plus 2 plus 1 is 4, minus 4 is 0. Okay? Or more formally, p of 1 as a function is 1 cubed plus 2 times 1 squared minus 4 times 1 plus 1. And we know that that's 1. That's 2 because 1 cubed is 1, 1 squared is 1. Minus 4 plus 1 equals 0. All right, so p of 1 is 0 means x minus 1, not x plus 1. X minus 1 is a factor of the original polynomial. Okay, so remember the way the factor theorem works. Okay, so if I plug in 1 and I get 0, x minus 1, not x plus 1, is a factor of the original polynomial. Okay, and a little timeout. Suppose I plugged in negative 1 and I got 0. That means x plus 1 would be a factor. So it's almost like you have to change the sign. Okay. Again, emphasizing this on the factor theorem, page 148. If the polynomial p of x is divided by the linear factor x minus c, the remainder is p of c. In particular, the linear term x minus c is a factor of the polynomial p of x if and only if P of C is 0. So when you plug in C, you get 0. That means x minus C is a factor of the polynomial. Okay? Right, so we know that since I plug in 1, I get 0. X minus 1 is going to be a factor. All right, so we're ready to do the long division again. Okay, so the original function, x cubed plus 2x squared minus 4x plus 1, goes in the inside, divide by x minus 1. And I'm anticipating there's no remainder. All right, so we'll do the long division again. Take the first thing here and the first thing here. So what do you multiply x by to get x cubed? That would be x squared. Now take x squared times the whole thing. X squared times x cubed. X squared times negative 1, negative x squared. Parentheses, subtract. X cubed minus x cubed is nothing. Careful here, 2x squared minus a minus, so plus x squared, is 3x squared. Bring down to negative 4x and start all over. Okay, so again, first thing here, first thing here. What do I multiply x by to get 3x squared? 3x. So plus 3x. Now you go 3x times this whole thing. 3x times x, 3x squared. 3x times negative 1 is a negative 3x. Again, we're subtracting. 3x squared minus 3x squared is nothing. There's negatives all over here. Negative 4x minus a minus 3x. That's negative 4x plus 3x, which is negative x. Bring down to 1. Do it all over again. How do I go from here to here? First thing here, first thing here. So what do I multiply x by to get negative x? Negative 1. And now negative 1 times this whole thing, well, you just change the signs. So negative x plus 1. And of course, if this matches this, you don't really have to subtract. You know the answer is 0. All right, so there it is, x squared plus 3x minus 1. So this original polynomial, x cubed plus 2x squared minus 4x plus 1, I can now factor into x minus 1, x squared plus 3x minus 1. Now, this thing is not factorable, but we can use the quadratic formula to break it down. Okay, now I'm going to show you something called synthetic division. So what is synthetic division? All right, so when we're running through this long division, I showed you some long division yesterday also, and maybe the day before that. There's some stuff here that we can compress and make a little bit easier. Okay, now, we know that we always have things lined up. X cubed, this whole column is for x cubed. This is all x squared. This is all x. This is all numbers, right? Notice if I go all the way down, these are all numbers. All the way down here is all x's, x squared and x cubed, right? All right, well, suppose we say, I'm just not going to write the x cubed, x squared, x, and number. I know it's there. I'm just not going to write it. Sort of like what I have here. Okay? I'm just going to put the coefficients. 1, 2, negative 4, 1. So suppose I just put 1, 2, negative 4, 1. That's really the same information as this 1, 2, negative 4, 1. Okay? I know the way the game works. Those are numbers. Those are x's. Those are x squared. Those are x cubed. Okay? So how about I say, I'm just not going to put x, x squared, x cubed. I know they're there, but look at how many times I have to write it, right? X cubed, x squared, x squared, x squared, x, and so on. How about I say, okay, as long as I have everything lined up, straight up and down, I know this is numbers. I know this is x. I know this is x squared. I know this is x cubed. Okay, that's what we have here. And the other thing you may notice, okay, right here we kept subtracting, right? Subtract. That's the way we did long division of numbers, right? Subtract, 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 and so on. And it's sometimes tricky because you have to end up doing a double negative, and sometimes there are 3 negatives involved, like over here, right? Negative 4x minus a minus 3x. There are 1, 2, 3 negative symbols, and we don't like to have that many negatives. Okay? So we'll adopt this policy. Okay, we know that if we subtract, it's the same as adding the opposite. right? If you subtract something, you add the opposite. So if I say subtract 3, you could also say add negative 3. That means the same thing, right? Or if I say subtract 7, I could add negative 7. So since we usually like adding better than subtracting, rather than putting a minus 1, I'll put a plus 1 and add. Okay, so one more time, instead of subtracting, I'll change the sign of this and instead add. Okay. And that way, over here, I just put 1. See, what happened to x? I know it's there. I'm not going to put it. Okay. So shortcuts for synthetic division. We don't bother putting the x squared, x cubed. We know it's there. So I'm just going to put 1, 2, negative 4, and 1. 1, 2, negative 4, 1. Notice when I do this synthetic division, there's no letters. There's no x's. Okay. And for this synthetic division, it only works when I divide by a first-degree polynomial, like x minus a. So you can't do it if I'm dividing x squared or something like that. Only x minus a. If I know it's x minus a, I say I'm not going to write the x. I know it's there. I'm just not going to put it. And I will change the sign and add. So instead of putting minus 1 and subtract, I'm going to put plus 1 and add. So I'll add everywhere. And that's nice because that will now match the 1 that I was plugging in over here. Way back up here, I was plugging in 1, right? So in synthetic division, I'm going to put the 1 here. Okay, so that 1 represents x minus 1. I can barely show you both. Yeah, see that x minus 1 is the same as that 1. Yes, this sign got changed because instead of subtracting, I will now add. And that 1, 2, negative 4, and 1, that's the same as that 1 x cubed plus 2 x squared minus 4x plus 1. Okay? In the back of my mind, I know that's a number, that's an x squared, that's an x cubed. Okay? Now, follow the logic. We're just going to add and multiply. It's a lot of addition and multiplication. So here we go. This one just drops straight down. Now I multiply. 1 times 1 is 1. Add. 2 plus 1 is 3. Keep doing it. Multiply. 1 times 3 is 3. Add. Negative 4 plus 3 is negative 1. Multiply. 1 times negative 1 is negative 1. Add. 0. This thing here is the remainder. That represents no remainder here. Okay. Now, notice at the bottom I have 1, 3, negative 1. 1, 3, negative 1. 1, 3, negative 1. It works perfectly. Right? You say, will it always work? Yes, it'll always work as long as I'm dividing by a first-degree polynomial. That means x minus a, only x, no x squared, no x cubed, and so on. Okay? But you will notice, instead of, look at all the x's that I had to write, and look at how much space I'm taking. Say, forget all the x's, just put 1, 2, negative 4, 1, 1, 2, negative 4, 1. Instead of putting in x minus 1, don't even put the x. We know it's there. I will change the sign of negative 1 to positive 1, and instead of subtracting, add. Notice we got the same answer. So add, 1 plus 0 is 1. Multiply, add, multiply, add, multiply, add. So one more time, 1 times 1 is 1. Put that there, and add. Okay. Wasn't that the same as if I had negative 1, I would go 2 minus a minus 1 way back up here. See that? 2 minus a minus 1, 3. Say, well, forget that. Just change the sign and add. And keep doing it. Multiply, add. Negative 4 plus 3 is negative 1. Multiply, add. 0. Okay. Now, how do I read that? Okay. It's usually best to start at the right. The very right is a number, and then x, and then x squared. X squared plus 3x minus 1. X squared plus 3x minus 1. Okay. So you know if I divide by x minus 1, the degree goes down by 1. So it started off with third degree, right? If I do this division, I end up with second degree. X squared plus 3x minus 1. Okay, so this is something called synthetic division. And by the way, look at how much more compact this division is compared to this. Look at all the space. Look at all the x's I had to write. This is much more compact. There aren't any x's at all, and I get the same answer. I just have to know to interpret this as x squared plus 3x minus 1. We're going to do a lot more synthetic division here, and I'll show you how they work. Okay. After a while, if you get the hang of synthetic division, it's much, much better, much, much faster than doing this long division stuff. Now, I want you to know both, so when we have the exam further down the line, you know, when's our next exam? October 9th, I guess, so it's not for a while. I want you to be able to show me both synthetic division and long division. Okay, so try to follow along what's going on with synthetic division. I've only done one example today, but you know, I'll do a lot more. Anyway, let's finish this problem. How do I do x squared plus 3x plus 1? That's not factorable, so I use the quadratic formula, right? So a is 1, b is 3, c is -1. Here's our quadratic formula again. You've seen it many, many, many times, but if you really need it, you can put it on your cheat sheet. But if we were meeting face to face, I'd make you guys memorize it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so negative b is -3 plus or minus square root b squared, 3 squared is 9, minus 4ac, 4 times 1 times -1. Okay, that's a double negative, so it's 9 plus 4, which is 13. So -3 plus or minus the square root of 13 all over 2. So my two x values are -3 minus radical 13 over 2, -3 plus radical 13 over 2. Okay, now I have to translate that into way up here, the factorization, before I show you that a little bit more. This looks messy, but remember, suppose it's at x equals 5, you would go x minus 5, right? Well, let's say this came out to be -2. The factor would be x minus a -2. So you have to go x minus that whole thing, x minus that whole thing. Okay, so it's going to be x minus that, x minus that. So here we go. Now this is considered completely factored, although, you know, this looks really weird. Okay, so x minus 1, we already had that way back over here, x minus 1. And yes, you can factor this into x minus -3 minus radical 13 over 2, and x minus -3 plus radical 13 over 2, right? These were the two solutions I got by using the quadratic formula. Okay. So technically this is it, but you can clean it up. I don't like all these negatives. See how you have negative, negative, negative? I can make them all positive. And if I distribute here, this will be a plus, that's a plus, and that's a minus, but that's considered a little bit nicer. That is one fewer minus sign. All right, so here's the best final answer of all. X minus 1. If I distribute the minus here and here, it's x plus 3 plus radical 13 over 2, and x plus 3 minus radical 13 over 2. All right, so here's the complete factorization of this thing, x cubed plus 2x squared minus 4x plus 1. And yeah, the only way to do this, you can't do that by the rational zeros theorem. I mean, these aren't rational, but we can only do that once we get to a second degree expression like this. Of course, we can always just use quadratic formula to continue the factorization. Okay. All right, next I'll show you 23. So that's a pretty long one. Fifth degree, factor completely. So if I factor completely, there's going to be 5 factors, right? See, if I synthetically divide or long division, I'll get it down to x to the 4th, right? Do it again, you get x cubed. Do it again, x squared, and so on. So there should be 5 factors. So you should have paren, 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 paren. 5 sets of parentheses if I do it properly. Okay, so that big long thing there is here. Okay, so here we go. So what are the possible rational zeros? Okay, so from last time, so it's plus or minus a factor of 3. You could say -3, but it doesn't matter. You're doing plus or minus anyway. Okay, so the way the rational zeros theorem works is plus or minus a factor of 3 divided by plus or minus a factor of 2. Okay, rational zeros theorem that I gave you yesterday. What are the factors of 3? 1 and 3. What are the factors of 2? 1 and 2. Okay, so what are the possible rational zeros? Okay, so how do you write them all? I just kind of cover up the 2. So you take all of the numerators and divide by that. So 1 and 3 divide by 1. Well, if you divide by 1, you have plus or minus 1, plus or minus 3. You then take all the numerators and divide by 2, plus or minus 1/2, plus or minus 3/2. Okay? So these are the quote-unquote only numbers to try. That's still a lot. That's 1, 2, 3, 4 times 2, 8. You only have 8 numbers to try. That's going to take a while, but 8 is far less than infinity, right? Now, none of these might work. We're not guaranteeing any of these work, but we're saying if the number is not on this list and it's a rational number, it definitely doesn't work. So 5 will not work. Negative 21 will not work. 1/3 will not work. Okay, so that's the way the rational zeros theorem works. All right, well, the easiest thing to try is 1. So let's just try 1. I'm looking for a remainder of 0. Okay, now, please notice how the synthetic division works. If I did long division, I would have to write that whole thing like this, right? So I go 2x to the 5th plus x to the 4th minus 12x cubed plus 10x squared plus 2x minus 3, and then divided by, and then if there's a 1 here, you'd have to put x minus 1, and then do all this stuff, right? Okay, but look at how much easier it is. Can you see what I'm writing? I'm only writing 2, 1, negative 12, 10, 2, and negative 3. See, what about the x and x squared and x cubed and x to the 4th? Okay, it's there. We know it's there. We just don't feel like writing it. Okay? When we were doing the long division, like today and all of yesterday, it's key that everything is lined up, right? The numbers are all lined up. The x's are all lined up. The x squareds are all lined up. X cubed is lined up. So we say, I'm just not going to write it. I know it's there. I know this means, okay, this means a negative 3. This means 2x. This means 10x squared. This means negative 12x cubed. This means x to the 4th. And this means 2x to the 5th. Okay. All right, I'm trying 1. So here we go. And the procedure is multiply and add. If you want to put that on your cheat sheet, you may. As a matter of fact, if you want to just put this entire example on your cheat sheet, you may. Okay, but you're just multiplying and adding. Multiply, add, and so on. Okay, so follow the logic here. 2 comes straight down. Okay, multiply by 1, 2, add, which is the same as subtracting the opposite from over here. Okay, so 3. Multiply, 1 times 3 is 3, add, negative 9. Multiply, 1 times negative 9 is negative 9, add, 1. Multiply, 1 times 1 is 1, add, 2 plus 1 is 3. Multiply, 1 times 3 is 3, add. Okay. I draw a line here to separate the remainder is 0, and now this is the new polynomial, okay, which I'm going to read off as numbers, x, x squared, x cubed, x to the 4th. Okay. So this original polynomial, I can now factor as x minus 1. Remember, if you put a 1 here, that means the factor is x minus 1. You change the sign. Okay. By the way, if this had been a negative 1, can you think what I would put over here? X plus 1. And notice I started off with x to the 5th. It's now x to the 4th. It's always that way. Okay. The language we say is it's depressed. The equation gets depressed by 1. So it used to be 5th. It's depressed down to 4. Next time I do it, it will be depressed down to 3, and then 2, and 1, and finally it's all gone. All right. So I've got that. Now I have to figure out factors of this. Well, I might as well try 1 again, just because I like 1. Okay. So notice how much less writing there is. 2, 3, negative 9, 1, 3. You say, where are you getting these numbers from? That's 2, 3, negative 9, 1, 3. 2, 3, negative 9, 1, 3. I know this means numbers, x's, x squared, x cubed, x to the 4th. There's no law against trying 1 again, so I'm deciding to try 1. So in other words, I'm looking for a multiplicity in 1. Okay, 2 comes straight down. And now we just multiply and add. Okay, multiply. 1 times 2 is 2. Add 5. Multiply. 1 times 5 is 5. Add negative 4. Multiply. 1 times negative 4. Negative 4. Add 1 minus 4, negative 3. multiply. 1 times negative 3 is 3, negative 3, and 0. I again get a 0, so I have another factor of x minus 1. And how do I read this? You always start at the right. So this is units, x squared, x cubed. So it started off with x to the fourth. It's now x cubed. So I now have x minus 1 squared, because this means I have an x minus 1. This also means an x minus 1, so x minus 1 squared. And I just read out the coefficients. 2x cubed plus 5x squared minus 4x minus 3. See that? It's much more compact than you keep writing all these x cubes and all these x squared, all these x's. We just say, how about we just don't write it until the end? I know this means, numbers, x's, x squared, x cubed. Okay, so we have this. And there's no law against trying 1 again. In fact, I can already tell by the remainder theorem that 1 is going to work. Okay? Because if I plug in 1, I'm still supposed to get 0, right? So plug in 1, 2, plus 5, 7, minus 4 is 3, minus 3 is 0. So that again tells me that 1 should work. So I'm doing 1 again. So it looks like I have a multiplicity of 3 minimum. Okay, so 1. That's just like putting x minus 1 over here. But 1. 2, 5, negative 4, 3. Notice 2, 5, negative 4, 3. So do it all over again. 2 comes straight down. Multiply, add, multiply, add, multiply, add. So 1 times 2, 2. Add, 7. Multiply, 1 times 7, 7. Add, 3. Multiply, 1 times 3 is 3, 0. The remainder is 0 again. So I have x minus 1, 1, 2, 3 times multiplicity 3. And again, how do I read this? Numbers, x's, x squared. So 2x squared plus 7x plus 3. And now that looks like something hopefully we can factor from algebra 1. So I have x minus 1 cubed. I do my parentheses. Plus plus always means plus plus. 2x squared doesn't really have any choice. 2x squared, one of them's got to be 2x and the other's x. And 3 doesn't really have much choice. You're either going to put a 1 here and a 3 here, or switch it 3 and 1. Okay, so this is how it actually turns out if you do it the right way. 2x plus 1, x plus 3. I'll leave it to you to try to verify that on your own. But that if you put a 3 here and a 1 here, you don't get the same thing. Well, yeah, you can FOIL it out. 2x squared plus 6x plus 1x is 7x plus 3. All right, so this thing is completely factored. So this big, long, 5th degree equation should have 5 factors, right? And that makes sense because how many x's are there overall? There's 5 of them, right? There's going to be an x cubed, and then another x that'll be x to the 4th, and another x that'll be x to the 5th. All right, so it's completely factored. Now find the zeros. The zeros are 1 of multiplicity 3. And what number makes this 0? If you do a little bit of algebra, it's negative a half and negative 3. So we're done. Okay, so that was quite a long one, but that's how that one goes. All right, then problem 35. I'll show you. I'll say a quick word about 33. Determine a polynomial of least degree whose graph is shown in the figure. Okay, well, how many zeros are there in 33? Which means how many times does it touch the x-axis? 1, 2, 3, 4. So you know there's going to be x plus 3, x plus 1, x minus 1, x minus 4, I guess it is. You don't have to write that down. The main thing is that there's going to be 1, 2, 3, 4 zeros. So it has to be at least 4th degree. So the answer for 33 is 4th degree because there are 1, 2, 3, 4 zeros. So to write the polynomial, you have to have at least x plus 3, x plus 1, x minus 1, and x minus 4, it looks like, in this particular case. There are 4 zeros, 1, 2, 3, 4. All right, then I'll show you 35, and then that's pretty much it for the section. So do you do weird stuff like this? So I'll do 35. I'll let you do 37 on your own. Then I'm finished with the section. Find a fourth degree polynomial. That means it's x to the fourth. The zeros are 0, 1, -1, and -2. Okay, that's pretty straightforward because that means you're going to have x minus that, x minus 0, x minus 1, x plus 1, and x plus 2. But now they have this other weird thing whose x squared term has coefficient 5. So what does that mean? How do I do that? Okay. All right, so it's fourth degree. X is 0, 1, -1, and -2. And they're saying the x squared term has a coefficient of 5. All right, so P of x, temporarily ignore the k. Okay, so this tells me I'm going to have x minus 0. X. The 1 means x minus 1. The -1 means x plus 1. And the -2 means x plus 2. Okay, so right now this polynomial works. Okay, for the zeros. You can tell what happens when you plug in 0 everywhere. Put a 0 here, 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 and here. Well, putting a 0 here wipes everything out. You get a 0. Okay. And you also know that 1 works. If you put a 1 here, 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 and here, well, 1 minus 1 is 0, so 0 times all the rest is 0. If you plug in -1 here, 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 and here, -1 right here, -1 plus 1 is 0, so 0 times all the rest is 0. And likewise, if I plug in -2 here, 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 and here, -2 plus 2 is 0, so 0 times all the rest will be 0. But I could be multiplying by some constant k. Well, k cannot be 0. If it's k 0, that wipes everything out. But k can be 2, 3, -7, a half. Pretend right here was 7. You would still have zeros at x equals 0, x equals 1, x equals -1, x equals -2. That wouldn't change it, right? If I have a constant in front. Suppose right here I had -1,000,000. -1,000,000 was k. The zeros would still be 0, 1, -1, and -2, right? So I'm just going to put the k. I will account for it later, and I'll show you how to do that. So the first thing I'm going to do is leave the k alone. I'm going to multiply all this mess out. Okay. So how do I multiply it out? I know x minus 1, x plus 1. That's x squared minus 1, right? So these two right here is x squared minus 1. Then I distribute the x. That's x cubed minus x, right? X times that, x cubed minus x. And then I decided to multiply this all out. So what is x cubed minus x times x plus 2? So FOIL. X cubed times x, x to the fourth. X cubed times 2, 2x cubed. Negative x times x, negative x squared. Negative x times 2, negative 2x. Then I distribute the k. So k times all this stuff, okay? So k x to the fourth plus 2kx cubed minus kx squared minus 2kx. Right? All right, now here's the key part. It says x squared has a coefficient of 5. Okay, so the thing in front of the x squared has to be 5. This is what it looks like right now. So I want negative k to be 5. So that means I want k to be negative 5. So one more time, they said x squared has a coefficient of 5. So way back over here, I got the zeros from x, x minus 1, x plus 1, x plus 2. But we know we could be multiplied by some constant k. I need to figure out that k because they told me the x squared coefficient is 5. All right, so I multiply all this junk out. Okay, I now have this long thing, and now I want the x squared coefficient. The thing behind my pen has to be equal to 5. Right now it's negative k. So I want negative k to equal 5, which means k is equal to negative 5. All right, so I just put k as negative 5 right there, and I'm done. So here's my p of x. Negative 5x, x minus 1, x plus 1, x plus 2. Okay, so if you multiply all that out, I don't feel like doing it anymore, but you could do it easily. Okay. The x squared coefficient is 5. And you still have these zeros, right? When x is 0, you get 0. When x is 1, you get 0. When x is negative 1, you get 0. And when x is negative 2, you get 0 also. Okay. So there we go. All right, folks, I'm actually done now with what I was going to give you in 3.3. Okay, so technically, I'm done for the week, but you know, I'll get ahead a little bit if I can. So 3.4, I'll just give you an introduction in the last few minutes, and then I'll let you go. Okay, so 3.4 is something called rational functions. Okay. Oh, and a quick reminder, I forgot if I showed this to you already, but for those of you that are never getting the book, okay, I'll do it. I don't mind redundancy. Page 154, okay, 3.3. So here's some of the problems. And the bottom. And then top of 155, and that should do it. Okay, so 3.4 is on rational functions. These are much harder. Okay, it's a polynomial divided by another polynomial. It's a ratio of polynomials. Here are some examples. X plus 2 over x squared minus 1. 1 over x. X squared minus 2x plus 1 over x to the fourth plus 2x squared plus 5. Don't write these down. Okay, the main thing is you have a polynomial on the top and a polynomial on the bottom. Okay? And of course, we already know we're not allowed to divide by 0. Right? So we have to consider the domain. Right? We know how to do that. Right? So it looks like for this one, x cannot be plus or minus 1. This one, x cannot be 0. This one, this domain is all real numbers because the denominator is always positive. Right? X to the fourth cannot be negative. 2x squared cannot be negative. The smallest these two can ever be is 0. But then when I add 5, it's always positive. Right? So this one, the domain is all real numbers, it looks like. Okay, what are we going to be doing? We're going to learn how to graph weird stuff like this, and like this, and like this. Again, don't write these down. This is on page 157, if you want to take a look at it. You're saying, how am I going to graph these and these? We're going to have asymptotes. Remember asymptotes? An asymptote is a line that the graph gets really, really, really close to. Right? This is called a vertical asymptote. This looks like a horizontal asymptote. So how do we spell asymptote? Here it is. A-S-Y-M-P-T-O-T-E. Plural is S. Okay. We also have a slant asymptote. See this? This is a slant asymptote, S-L-A-N-T. It's kind of tilted, right? So that's going to be a slant asymptote. I'll show you how to do those. Okay, so we can have vertical asymptotes. Horizontal asymptotes. This is on page 160. Okay, so I'll hold this here in case you want to look at this in the text a little bit later. Okay, I'll go over it in the upcoming days. And maybe I didn't show you this long enough. Okay, so definition of a rational function, polynomial divided by polynomial. 3.4, that's on what page? 155. Okay, vertical asymptotes. Okay, you want to look at that. And it's on page 157. Okay, then we have slant asymptotes, page 164. Slant asymptotes like this. Okay, we get real close to, I don't know, y equals x minus 1 or something like that. Okay, and now the problems. Okay, so 3.4, page 168. All right, so there's some problems there. Get this yellow out of here. Can't seem to get rid of the yellow. Okay, then on page 169, some there. Some more. And some more. All right. Page 170. Okay, so That's up to about 35-ish. All right, so that's about it, folks. So we're done. Stop the share. Okay, time is about 6 or 7 minutes left. Okay, let me check the chat. I don't see anything in the chat. All right, so I'll take any questions, and if not, we're done for the day, folks. So tomorrow I'll lecture for a while, 30 minutes, 35 minutes, and then I'll stop, give you the quiz. The quiz will be on section 2 and 3 most likely. And just like all the other quizzes, I'll put you in your breakout groups. You can talk about it. And then you have until Monday morning at 9 o'clock to submit the quiz, okay? All right, any quick questions now, please? Otherwise, we're done for the day. All right, that'll do it for today, folks. So have a good day. See you next time. Thank you. Bye.